Today we are continuing in our unit on matrices and vectors. Today we're going to be doing an application of matrices. When I think of what I can do with a matrix, the very first thing that comes to mind is solving a system of equations. And that's what we're going to be focusing on with this application of matrices. I will tell you, anyone that is going to go into computer science or into a computer software field, you are going to need to take linear algebra, and you will do a lot more with matrices. So there is a lot more to do with matrices than what we do in PreCalculus. In PreCalculus, we just give you a little bit of a reminder of what matrices can do, what their strengths are. So if I was going to solve this by hand, it would be a long process, okay? Probably a good half a page of paper, and multiplying, adding, subtracting, combining. It takes a long time to solve a 3x3 system of equations. This would not be so bad, and I probably would solve something like this by hand before I went to a calculator to do it. But I'm going to show you how to do that on the calculator anyway. This one would take a long time. This 4x4 system, it would probably fill up a whole sheet of paper to solve by hand. With a calculator, it's a couple of easy buttons after you have the matrix put into your calculator. It's just a couple of easy buttons to get the solution. So first of all, we need to talk about what this augmented matrix is. Okay, so an augmented matrix is the matrix formed by taking the coefficients and the other side of the equal sign. That's probably called something. It's the augmented. We are going to create a matrix by using the coefficients and what the number on the other side of the equal sign. Okay, so I'm going to create this matrix. There's a 3. The first term in row 1, column 1 will be a 3. Then we'll have a 4. The coefficient on that z is a 1. And then I'm going to put a 5 over here. Okay. I do need to remember that there's an equal to sign there, though. Okay. Let's not forget that. So then we'll have a -9, a -1, a 7, and a -12. There is no x term. That means its coefficient has to be a 0, 2, 7, and 20. And what we do is we put a little dotted line through there to remind ourselves, yes, there is an equal to sign. And that is the augmented matrix. That is what we'll put into our calculator, except we're not going to be able to put in that dotted line. Okay? All right. What we're going to do with this matrix is we're going to write it in what is called reduced row echelon form. Now, if we were solving this system of equations by hand, we would, I might, since I see these 7 z's are the same, I might multiply one equation by a -1 and then add these two equations. That would give, and then I would get an x and a y, and then I would go and try to substitute in. I would do some different things. My point being, it is legal to multiply both sides of an equation by a number, right? That's mathematically legal because we are multiplying both sides by that same value, right? And since it's equal to, we can do that. It is also legal to add two equations, right? We add two equations to try to eliminate a variable, yeah? So if we multiplied by a -1 and then added these two, I would be eliminating, well, I would be eliminating the z's, but I would be getting an x, so that we'd have to think about that. It is a real pain to do that process by hand, okay? So that is a real strength of doing this in our calculator. we can let our calculator do all of those for us, and that is called getting it in reduced row echelon form. Okay? So it's going to do all of that for us. So let's talk about that with this one. So I'm going to first just put this into our calculator. So let's go to, okay, pretend, okay, I had this in there because I just made my previous video, but we're going to go to the matrix function of the calculator, so that the key is right here. So we're going to do second and then that inverse key, and that will pull up the screen. That pulls up the screen, okay? Now, I am going to go to edit because I want to put in a matrix. So I'm going to go to edit, and let's go ahead and click on number 1 for matrix A. Now, this matrix in number 4 is a 2 by 3 matrix. So I need to put 2 by 3. And you see it gives me the same, it should reflect what you're looking at here. And now I'm going to put this in -2. Now, right now it's filling in the location for row 1, column 1. When I hit enter, it automatically goes over here to, it stays in the same row, goes to the next column. Okay? So I want to put in that 1, enter, and then the 10, enter, and now I'm down in row 3, and now I'm down in row 2. So just know that it goes sideways. When you hit enter, it's going sideways. Okay, so 3, 4, -15, you'll probably get pretty quick at putting those in. I always take a quick look to make sure that I put it in there correctly, make sure it's identical to what I'm looking at. Okay, once it is, I go to my home screen. Home screen, second quit. Second quit gets you out of matrix screen. Okay, now I want to go back to matrices because I want to use one of the math features there. So I'm doing second matrix, and I want to go over to math. Okay, now the reduced row echelon form button is not visible on this first screen. We have to scroll down further. So let's scroll way down, right there. Do you see the RREF? That says reduced row echelon form, RREF. Okay, so click enter on that. It puts it on our home screen, and now we want to put in matrix A because that's where we put this matrix. So go back to your matrix screen, second matrix, and just hit number 1. That's your A. So it's going to look like this, and I hit enter, and it gives me the matrix in reduced row echelon form. I should go through the process of how to do this by hand, and then you would really appreciate what your calculator is doing, because it is a pain to do this by hand. In class I might do that. So this is 1, 0, -5, 0, 1, 0. Now keep in mind, if this was a system of equations, this would be an equal to sign here, so this would be an equal to sign here. So this would be giving us 1x is equal to -5. So 1x plus 0 is -5. 0x plus 1y is equal to 0. So it's giving us the answers right there. Okay? But this is reduced row echelon form. For this problem, that's all we wanted to do. For these next ones, we're going to be finding the values of x, y, and z, or whatever variables they are. Okay? So, for number 3, I'm going to first write my my augmented matrix. So I want to see your augmented matrix. So my first equation is 1, 1, 0, 5. And then my second equation is -2, -1, 2, -10. And my last equation is 3, 6, 7, 14. And I know that there is an equal to sign here. Let's not forget that there's an equal to sign there. Okay, so we're going to go put that into our calculator. Matrix. I think I'm just going to edit matrix A. So what is the order of this matrix? It's a 3 by 4. So I'm going to do 3 by 4. And I go across the row. So 1, 1, 0, 5. Enter, and that should be my first row, 1, 1, 0, 5. And then my second row, -2, -1, 2, -10. And after you hit enter, you should have that in. And then 3, 6, 7, 14. You guys do not forget to hit enter that very last time. It's very common for students to leave the previous value there because you had it here but you didn't put enter. Put enter, make sure it's in there. Make sure your screen looks like your matrix here. Okay? And I'm doing just that as I'm talking, and it does look like it's correct. So that is my matrix A. And now I want to write the reduced row echelon form of that. Now, on my calculator, it allows me to scroll up. So I'm going to scroll up, grab that, and hit enter again, and it's using my new matrix that's in there. So the reduced row echelon form is 1, 0, 0, 3, 0, 1, 0, 2, 0, 0, 1, -1, and there's my equal to sign. So I know that x is equal to 3, y is equal to 2, and z is equal to -1. And those are my answers. A little bit off the screen, but those are my answers. Okay? And that's how we do that. I'm going to do one more with you here. I don't care which one we do. Let's do number 4. They're all very similar. There are none that are harder than others. They're all very similar. Okay, so this is another 3 variable system of equation, 3 equations, 3 variables. So it's going to be very similar to what we just did. I'm going to write my augmented matrix. So 1, 2, -3, -28, and then 0, 4, 2, 0. That's my second equation. And then -1, 1, -1, and -5. There's my equal to sign. Okay. Go back to my matrix screen. Go to edit. It's still a 3 by 4 matrix, so I don't have to change that. I just have to change all my numbers. So I'm going across the row. 1, enter. 2, enter. -3, enter. -28, enter. That takes care of the first row. 0, enter. 4, enter. 2, enter. 0, enter. That should give me my second row. -1, enter. 1, enter. -1, enter. And -5, enter. Again, I know I've said this, but don't forget that last enter. Make sure that your matrix looks like it is on your paper. And I'm doing just that as I'm talking, and I don't think I've made any errors. So I'm going to go second quit, go to my RREF, I just scroll up to my RREF of A, hit enter, and there's my reduced row echelon form matrix. So 1, 0, 0, negative 4, 0, 1, 0, negative 3, 0, 0, 1, 6, and that's it. So when I took this class, it was way before these calculators. It's way before we could do these on the calculator. And when I first saw that the calculators could do this, I was blown away because I had spent numerous hours solving a system of equations like this by hand. Very impressed the first time I saw this, and I still am. So x plus 0y plus 0z is negative 4. 0x plus y plus 0z is negative 3, so y is negative 3. 0x plus 0y plus z is equal to 6, so z is equal to 6. Very impressive with what these calculators can do. And that is how we solve a system of equations with a calculator. Okay, got just a few for you to do here. And then to fill up a little space, I have some review of trig functions, unit circle values, and a review of these graphs. So I do want you to do those. I know it's not matrices, but I do want you to be able to do these. Very important for calculus, so a little review in this unit. Otherwise, we wouldn't be doing any of this in this unit. Okay, that's it for solving systems of equations with matrices, and that is it for our study of matrices.